All right. Good morning, everyone. Thank you for joining Forensic Analytical Consulting Services today for our webinar on silica and asbestos regulations in the construction industry. Today's webinar will be hosted by Forensic Analytical's very own Michelle Rosales, who's a CIH and a senior project manager here at FACS, as well as Steve Long, who's a CAC and also a senior project manager here. Before we go over the agenda for today's webinar, I wanted to quickly cover the webinar platform we're using, GoToWebinar. So everyone will start in listen-only mode except for the presenters in order to reduce background noise. So this means your phone is automatically muted. However, this does not mean you cannot communicate with us. As questions arise for you throughout the webinar, we ask that you enter them into the questions or chat box on your screen. Make sure to select the option Send Question to Staff before submitting. And at the end of each presenter section, we'll cover all questions that come up. So please don't be shy. And as far as what we'll be covering in today's webinar, the presentation will begin with Michelle, who will be diving into silica and its new regulations. And the second portion, led by Steve, will be covering asbestos regulations and how they apply to newer buildings. Although we thought asbestos would be dead in 2018, there are still many issues involving asbestos and even in those newer buildings. So now I'm going to hand it over to Michelle Rosales, and she can get started.
Thank you, Taylor. Good morning, everyone. Thanks for attending today's webinar. As Taylor said, my name is Michelle Rosales, and I'll be presenting on some of the new silica standards, looking at Cal OSHA, a little bit of Washington and Oregon as well, and going over the federal standard. But we're going to be talking specifically regarding the construction industry. So why are we here today? And why should we care about silica? Well, OSHA estimates about 2.3 million workers are exposed to crystalline silica daily. 2 million of those being individuals in the construction industry. To better protect workers exposed to respirable crystalline silica, OSHA has issued some new standards on silica. One for the construction industry, which we're talking about today. The other is for general industry and maritime, and there will be a new one coming out for fracking in the hydraulic industry. The main point is that OSHA wants to protect the workers and help save lives with regards to silica exposure. So the health effects to silica have been known for quite a while. One of the most seminal events, both in silica exposure and general industrial hygiene alone, occurred in 1930 at Hawk's Nest Tunnel, which is in West Virginia. Workers were exposed to high concentrations of silica during pulverizing of rock to create this tunnel right here. By the time the work ended, an estimated 476 workers had died of silicosis, and an estimated 1,500 developed the disease within a year or two. And that's stated to be an underestimate of the amount of exposures and health effects associated with silica during this event. So that was one of the large events that caused and began to see silica as a very harmful chemical that would impact workers during the pulverizing and mechanical work that creates airborne dust with silica in it. So what is silica? Well, it's important to know that silica is everywhere. It's the second most common element in Earth's crust, oxygen being the first, and together they make up about 75% of Earth's crust, which we live on. However, in terms of health effects and the OSHA standard, we are looking at the crystalline form of silica, which can be also further characterized as quartz, cristobalite, and tridymite, and other rare forms. But in terms of the occupational exposure limits, we're looking at quartz, cristobalite, and tridymite. So silica is naturally occurring, as I just stated, and you can find it in sand, soil and rock, gravel, slate, granite, pretty much everywhere on the ground. But in terms of the construction industry, where are we finding it? Well, quartz is in concrete, brick, and mortar materials. And so typical exposures to the silica occurs during any mechanical work on these silica-containing materials. So, for example, we're not worrying about exposures to silica when we're at the beach, which is primarily made of sand, correct? But instead, we're looking for the respirable size fraction that can be inhaled into the lungs. So when you're thinking about the construction industry, it's when you're doing grinding, cutting, jackhammering, any of these type of work activities that would create this smaller respirable size fraction in the material. Also, mixing and handling of concrete. It's a larger size, but you can get those smaller pieces of respirable size particulates to adhere to the larger pieces. And when the airborne dust comes up, there's potential for respirable crystalline silica exposures. So what happens when you inhale these tiny little particles? Exposure to respirable crystalline silica can cause multiple diseases, including silicosis, which is an incurable disease that leads to disability and even death. It can sometimes occur without symptoms. However, symptoms do include shortness of breath and cough. Dust that contains this respirable crystalline silica can cause scar tissue known as fibrosis, which is shown on this X-ray right here on the right-hand side. And there are three forms of silicosis: acute, chronic, and accelerated. So if we're thinking about the Hawks Tunnel incident, there was a lot of accelerated forms of silicosis, which caused death within the 1 to 2 year time frame, and then later on the chronic exposures to additional exposure to crystalline silica for several years after this event. Additional health effects associated with respirable crystalline silica is other diseases such as tuberculosis, COPD. It also is a known carcinogen. And interestingly, studies of workers exposed to respirable crystalline silica have found that workers are at increased risk of developing kidney disease as well. So as previously stated, to reduce silica exposure and protect workers, federal OSHA implemented the respirable crystalline silica standards for construction industry, general industry, and the fracking industry. The standard requires employers to limit worker exposure to respirable crystalline silica and to take other steps to protect workers. So the construction industry was the first of the three groups to have the standard become enforceable. That occurred in September 23rd, 2017, which is last year. So hopefully if you are in the construction industry, you are already complying with the standard. And the standard not only applies for the standard does apply for job tasks that are found to have exposures that meet or exceed the action level of 25 micrograms per cubic meter. So this is the actual construction standard regulation right here for federal. Okay, my slides aren't advancing, sorry.
There you go.
There we go. Okay. So if your state has their own OSHA plan, then they were required to adopt a standard that is at least as effective as the federal OSHA standard. So right here I reference the California State Plan, Washington State Plan, and Oregon State Plan based on people who were intended for this webinar. However, when looking at these plans and various other state ones, from what I've seen so far, they're exact duplicates of the federal standard, just with a regulation name under that state plan itself. So again, as I've said previously, the standard requires employers to limit worker exposure to respirable crystalline silica and to take other steps to protect workers. So if you find that this standard applies to your workplace, meaning that you have employees or workers that are expected to be exposed to levels above the action level or at or above the action level, the standard has a list of key provisions that are necessary. So all of which I'll go into further detail, but a quick snapshot is there's a reduced exposure limit that you have to abide by. If someone's going to be above the action level, you need to generate a written exposure control plan, and I'll go into detail about that. The designation of a competent person, there's restricted access and housekeeping issues, medical surveillance, training your workers, that being HAZCOM, and also record keeping. So one of the biggest provisions with the new standard was the reduction of the permissible exposure limit. So if you were a state that previously followed the federal OSHA PEL, you had this funky calculation that you needed to use in order to determine the PEL. So it was dependent on the content of silica and the amount of dust, and it was a little troublesome trying to calculate that at times. Here in California, though, we didn't have that calculation. We just had just a specific concentration for specific types and forms of silica. So quartz had a specific number, which was 50 micrograms. Was 0.1 micrograms. 0.1 milligrams. And for crystallite, it had a smaller PEL. So now the concentration for quartz has been cut in half if you were in California, and the value is now 50 micrograms per cubic meter with an action level, which was previously not there, of 20 micrograms. Also in California, we previously had a total dust crystalline silica PEO, which has now been removed because, again, we're just worrying about the health effects associated with the respirable size fraction and not the larger size silica material. So if you're required to follow the standard, then you're required to have a written exposure control plan for all tasks that are expected to result in exposures at or above that action level of 25 micrograms. The written exposure control plan needs to include all controls that will be used to decrease the exposure to silica and to control your dust. This includes not only just engineering controls, but what other work practices, such as administrative controls, maybe reducing the amount of work someone can do with a specific work task, or the actual personal protective equipment they'll be using, what housekeeping measures are going to be used to make sure that the dust you create during your work doesn't impact other areas or those that may be coming in afterwards to clean up the area. And it includes an annual audit to help those think about reducing exposures and protecting workers on a continual basis. So here are a list of some exposure controls that we generally use for construction industry to help reduce exposures, not only to just respirable crystalline silica, but dust in general, which can contain a myriad of different chemicals. As for all industrial hygiene, I know I listed personal protective equipment here. That should always be the last line of defense. All controls listed should be evaluated first to see if you can reduce exposure levels that way before relying on personal protective equipment to be worn properly by your employee. The standard also requires the designation of a competent person, who is defined as an individual who is capable of identifying existing and foreseeable respirable crystalline silica hazard in the workplace, and this is very important, who has authorization to take prompt corrective actions to eliminate or minimize them. So this is important because they don't want someone's name just randomly thrown and added to a program, as you probably have seen happen before, but instead an individual who is competent, understands the workplace and the workers, and someone who is able to make decisions and changes as needed quickly without having to get authorization from higher ups. The standard also has a section on housekeeping, which is really great because its purpose is, again, to reduce exposure to those working in the area, but also to others that may be in adjacent work areas, different trades, or those coming in to clean up afterwards. I always try to tell people, again, let's not talk about cleaning, let's talk about controlling dust during the actual work task itself. So it's important to include this into your program. And it prohibits the use of compressed air and recommends the use of HEPA vacuuming during the cleanup procedures. Also, a large key provision in the standard is the medical surveillance program, which is new for silica exposure. And it is required for any employee who is required to wear a respirator for over 30 days in 1 year. The program includes baseline x-rays, periodic x-rays about every 3 years, TB tests to see if there's any potential lung issues prior to even beginning the silica work, and is very specific in the type of individual and physicians that can actually do the work and review the x-rays. Next is the hazard communication training, which is similar to all hazard communication training in that you need to train all your employees on the health hazards associated with the work they're doing, what work tasks and controls will be utilized for them to help protect them, listing the standard requirements, letting them know who is the identified and designated competent person, and then giving them some information on the medical surveillance program if they will be included in it. And again, the annual audit at the end for continual success and revisions to your program, because again, you may look back at your written exposure control plan and see that there's additional ways that you can reduce exposures to employees. So as stated previously, the standard requires employers to limit worker exposure to respirable crystalline silica and to take other steps to protect workers. So OSHA allows employers to use either the specified exposure control method, which includes this infamous Table 1, or follow the alternate exposure control methods, which uses general IH type of strategies in order to evaluate which control methods can reduce exposures. So employers who follow Table 1 exactly to the T are not required to measure worker exposure to silica. So they're not required to do any air monitoring to evaluate employee exposures. And they're not subject to the PEL. So again, if you're not monitoring, you're not subject to comparing and confirming that someone's below a permissible exposure limit. So if you're able to follow that Table 1, then you are not required to sample any employees. You cannot deviate from this table, however. So if it says that water suppression methods are needed for a specific job task, then you are required to use water suppression methods. Also, it's important to remember if your employees follow this table and you are using Table 1 and the specified exposure control methods as your means of controls, and the employee is going to be wearing the respirator for greater than 30 days, then they are again required to be put in a respiratory protection program and medical surveillance program. So it sounds wonderful that you don't have to spend money on this air monitoring. However, it's important to remember that there are specific requirements for respiratory protection in this table. And if you know your employee is going to wear it for greater than 30 days, then you need to spend the money for the respiratory protection program and medical surveillance program. This was kind of created to help smaller businesses who can't afford to pay for a lot of exposure monitoring and are fairly confident in exposures that will exceed the action level. However, by talking with several clients and assisting them in these new silica standards, it's not as feasible for larger companies or with employees that have high employee turnovers, or even, so there's been a lot of issues too with being able to always follow the standard. For example, if you are a construction company and you're working on the 26th floor and the Table 1 says if you're doing any grinding for less than 4 hours, you need to use water suppression methods, it may not be feasible for you or even possible at all to even get that amount of water up to the 26th floor in order to provide that as your dust control system. So it's a good table, but it doesn't always give you everything you may need, especially with different scenarios. So here's an example of table 1 and one of the equipment tasks. There's 18 different tasks listed in this table. And if you can see, the equipment task is handheld power saws with any blade diameter. And it tells you that you need to use a saw equipped with integrated water delivery system that continuously feeds the water to the blade. So if you're doing this work outdoors for less than 4 hours, they say that you do not need any respiratory protection protection. However, if you do it for greater than 4 hours, you need a sign protection factor of 10. So again, if you are doing this work on the 26th floor and you do not have the ability to bring water up to deliver it to your system, then you can no longer follow the table and therefore are now going into the next group, which would be the alternate exposure control method. So again, this is for tasks not listed in table 1 or where the employee cannot fully and properly implement the requirements of table 1. So for employees who may be reasonably expected to be exposed to respirable crystalline silica at or above the action level and do not want to follow table 1, we'll look at the alternate exposure control methods. So there are 2 options that you can use for the alternate exposure control methods. One is the performance option, which is using a combination of air monitoring data or objective data in order to determine whether your exposure controls work well. The objective data can come from prior assessments that you've performed maybe at other sites or at different times, different areas, but can be applicable to the work that you are proposing to do. Or if there's any industry data available. I know that the drywall industry has done a lot of research and exposure monitoring to help assist their trade in determining exposure based on a series of specific parameters. So if you can find a data that shows the work you plan on doing shows a certain exposure limit or a certain controls that will keep levels below the permissible exposure limit, then you can use that. Or you can go with the scheduled monitoring option, which uses just traditional exposure assessments, which is just general air monitoring periodically to confirm that exposures are at a certain limit and your exposure controls are sufficient. So if you decide that you are not going to be using table 1 and you want to use the alternate exposure control methods and sampling is necessary, this is a little bit of information of what it would entail. As previously stated, we're worried about the respirable size fraction, so the tiny particles that are inhaled and reach lungs. In order to filter out these larger particles that are also in the air and becoming airborne, we use a cyclone, which is on this right-hand side photo, which is attached to a cassette. And all the larger particles come in through this little slit here in the front, and the larger particles will settle down to the bottom of the cyclone. And the respirable size fraction is small enough and a certain size of diameter and weight that it will attach to the filter in the cassette, which is then sent to the laboratory for analysis. The new standard also has specific requirements for laboratories and what methods can be used and the actual detection limits that are necessary in order to perform the laboratory analysis in accordance with the standard. The 2 methods that are currently acceptable are NIOSH 7500, which uses X-ray diffraction, and 7603, which uses infrared spectroscopy. Both methods will provide results for all 3 forms of the crystalline silica, again, the quartz, tritonite, and cristobalite. And although that's what you need for the standard, I also like to have my samples weighed for just general dust, not just the silica, but everything else in there, because I find this very helpful when determining whether or not the exposure controls are sufficient. So we never really know how much silica is in a material, so it's good to look at just general dust itself to determine if current exposure control methods are sufficient in what is being done. So what should you do now that you've heard this portion of the presentation? Well, one, you need to determine if the standard applies to you. Do you have workers that may potentially be exposed to levels greater than the action level? If so, I hope you have begun the development of a silica management program. If you haven't, you need to start right away. And again, that includes a written exposure control plan, looking at each work task and developing which controls will be used, and how you plan on reducing exposures. It's important to discuss at the beginning which plan you think you may want to follow. There's pros and cons to both plans. Again, you need to look at the cost of medical surveillance, respiratory protection versus sampling assessment and looking at specific exposures for certain tasks. So how can facts help? Well, we have been helpful with other clients in developing or assisting in their silica management program creation or generation. Also, development of written exposure control programs, both company-wide or just project-specific. Development and review of respiratory programs. We've done hazard communication training for clients, training for the competent person, whoever that may be, exposure assessments, and also assistance in developing and obtaining objective data. So we can have some questions if there are any at this time.
And it doesn't look like any have come in yet, Michelle, but if anybody has any come up, you know, throughout the duration of this webinar, please put them into that chat box again. You can go to webinar tool and we can ask them out loud so everybody can hear the answers. Give it a few seconds here to see if any come in before Steve starts. All right, well, none yet, but if any come in, oh, it looks like one just came in here. So the question is, what about incidental exposures, i.e. drilling one hole through a foundation to pull a wire through?
So I've had that question a lot because you don't think, well, the standard says if you believe that there's reasonable exposure above the action level. So what I've kind of been telling people is maybe taking the time to actually just do an assessment and have the data available showing that when we do this certain amount of work in this time frame, we're confirming that we know we're below the action level and therefore no additional action is necessary. So drilling one hole, again, I think OSHA understands that that is not going to be an exposure issue. However, if you think you're going to be doing more than that and that there's a potential somewhere for someone to question it, then to perform an assessment just to confirm.
Alrighty, and it looks like that was the only question we have at this time. But again, if there's other that come up about silica, feel free to ask them throughout Steve's portion on asbestos as well, and Michelle can cover those at the end. So Steve, if you want to get started.
Sure. So what I wanted to talk about today was something that's a little bit anti-intuitive at times, and that is how the asbestos regulations apply to newer buildings. So what is a newer building? It depends who you ask. But I think 1980 is a date that a lot of people use, and certainly 1990 or 2000 would be buildings that most folks are considering newer with regard to asbestos. So the question here at the top is, do I need to test newer buildings? I'm going to lead with the spoiler, and that is yes. And what you see below here are some justifications and some backup material for that anti-intuitive type statement. So one item to consider is that the use of asbestos, contrary to popular belief, in building materials was never completely banned in the United States. It was attempted, but that was defeated. Many other countries have managed to implement a complete ban, but not here in the US. The EPA attempted a ban in 1989, but that ended up in the courts with some opposition from various manufacturers of building products. And through the 1990s, it was battled out and the manufacturers ended up winning on most counts. And so there are many, many products that remain legal to produce and to sell and to install in buildings even today. Again, contrary to what is popular belief out there. So does that mean I need to test? Well, hopefully by now, after looking at that previous slide, you've determined that yes, you would need to test in order to find out whether any of those particular products are installed in your building, if it's a newer building, say post 1980. But in the event that that wasn't obvious, EPA has issued some interpretations, as have many local and state agencies, to make it clear that since EPA did not provide a cutoff year in their regulation, that yes, they do require testing for asbestos prior to renovation or demolition for any building, regardless of the age. I can think of a building that's kind of my poster child for this one, where we did some testing while the building was actually still under construction. And that was a scenario where some water damage had occurred, and a lot of drywall needed to be removed to address the water damage. And the most expeditious way of determining whether there was asbestos present was to go ahead and sample the drywall that had just been installed, in some cases days or weeks previous. So it can get to sound a little bit ridiculous in a scenario like that, but you just have to go back to the regulation and realize that there's no cutoff. Some other regulations may provide a clear cutoff, for example, with lead-based paint, and that would be 1978 for residential buildings. And that relies on a ban. Yes, that was complete for residential, at least down to a certain level when we're talking about lead in paint. So speaking of bans, here the third bullet point on this slide relates to bans that have gone into place from EPA and others. So for example, in the 70s, the use of friable pipe insulation with more than 1% asbestos was banned, as was from the Consumer Product Safety Commission, the use of drywall joint compound containing more than 1% asbestos. Can we rely upon that and say, hey, I don't need to check the joint compound, I don't need to sample and analyze it in my 1995 building, or I don't need to sample and analyze the pipe insulation in my 2001 building? No, the answer is no. EPA does not allow us to rely upon those, although some may be thinking at this point, what about my fiberglass pipe insulation? Well, that would be considered a non-suspect material. So the inspector is qualified to make that judgment. And even in that case, we're frequently sampling the paper or the canvas wrapping that might be there on the fiberglass. So I'm certified in California as an asbestos consultant, so I just look to a couple of local agencies here in terms of how they address this issue. So the South Coast Air Quality Management District, which regulates asbestos in buildings for EPA here in the greater Los Angeles area, they have published a frequently asked questions on their website. And when the question was asked, you know, do I need to sample my newer building or my building that I feel doesn't have any asbestos in it, their answer was that yes, the survey needs to be conducted, quote, regardless of the structure age, unquote. Now, a little more, I think, useful, is the new San Diego rule 1206. This is from the San Diego Air Pollution Control District. So they regulate things in the San Diego greater area. And they've actually written it into their rule that an asbestos survey needs to be conducted, quote, regardless of the year of construction, unquote. So I'm kind of hoping that this is a new trend that we may see other state or local agencies, or perhaps even EPA at some point, writing this kind of explicit language into their regulation, because it is not intuitive for a lot of people. There's a widespread misconception out there that these newer buildings do not have to be tested. So by writing it into their regulation, San Diego prevents people from having to dive into, you know, the EPA website looking for letters of interpretation and that sort of thing. Looks like I repeated myself there on that third bullet point, but skipping down to the fourth, let's not forget that OSHA and Cal OSHA also require testing for asbestos. And similarly, they do not have a cutoff year for that testing. There is some potentially confusing language in the OSHA and Cal OSHA standard with regard to presuming floor tile to contain asbestos previous to a certain year. But that's not to say that the opposite is true, right? You are not able to presume that it doesn't contain asbestos after a certain year. So we know we have to test now. The question might come up, is there anything to really find out there? Or do we, in real life, find asbestos materials out there in these 1990s and 2000 buildings when we go out there and sample them? And the answer is yes. And of course, what we're finding is, for the most part, the materials that have not yet been banned. So some of the more common of those would be vinyl floor tile, the mastic under the vinyl floor tile. Very, very common material to find it in, if it's present, is mirror mastic. So mirrors that are stuck to the wall with an adhesive. Typically this occurs in black blobs of what we call hockey pucks, because that's the shape they take once the mirror is pressed onto it. You typically have to break the mirror to get at it and sample it, but every time I've done so, even in newer buildings, I found usually 5 to 10% asbestos in the mirror mastic. Zinc undercoatings, and I could have put et cetera, et cetera, et cetera. These are some of the more common, but there's lots of other products that we find asbestos in. Now, in terms of products that were banned, but sometimes do manage to sneak their way into the country, that has occurred as well. There have been reports of products coming in from Canada where they still actively mine asbestos, and from Mexico as well, that have been found during surveys. Also keep in mind that the bans that have gone into effect from EPA, those bans regulated only down to 1%. So theoretically, at least, it's perfectly legal to put in products that contain more or less than 1% asbestos. Not that the manufacturers are necessarily intending to do that, but there can be contamination. Many of these materials that go into different other products are mined materials, as is asbestos. And so sometimes you get the same kind of conditions that are conducive to forming some of these other materials are also conducive to forming a bit of asbestos in the ground. So some types of materials where we will frequently find trace amounts of asbestos, regardless of the date of construction, would be interior plasters, exterior stuccos, and also some fireproofings. We found particularly some of the less common types of asbestos, such as actinolite. It's not really there as an active additive, but more as a passive, contaminant that snuck its way in. So what should we do? Well, let's make sure that we test all buildings prior to renovation or demolition, regardless of the date of construction. Keep in mind that you don't have to do survey unless you're going to disturb some materials with renovation or demolition or repairs. Many, and I would say possibly most, newer buildings will have the intuitive result from that survey, and that is all the samples will come back from the lab with the result of asbestos not detected. And also remember that, again, OSHA and Cal OSHA regulate down to any detectable level of asbestos. So just because the lab says, hey, you're less than 1%, doesn't mean that this is a material that can be ignored. So what's the recommendation? Well, it would be that a specialty contractor be brought in to remove asbestos prior to most construction or demolition, regardless of the concentration that was found in the material. So in other words, even if it's less than 1%, most asbestos consultants are going to recommend that you go ahead and remove that material first prior to the construction or demolition, even though you may get some contractors that will say, hey, we can handle that. There are other issues. And the reason I say most instead of all construction or demolition is sometimes you will get a situation where a trace amount, a very small amount of asbestos is so pervasive throughout, let's say, exterior stucco, that maybe it does make sense to do asbestos control as part and parcel of your demolition. And keeping in mind here on the second bullet point that there's no safe level of exposure to asbestos that's been established. So even low levels we want to be concerned about and control to the maximum extent possible. And by doing so, these kinds of precautions are going to protect primarily the building owner's risk. And from a human point of view, prevent exposures not just to the workers, the construction workers or the demolition workers, but also you have to consider there are other building occupants that may be exposed if they're nearby. If it's an outdoor site, you may have passersby that could get exposure, and sometimes the wind may carry asbestos fibers off the property to nearby sites. So those are all deserving of consideration. Okay, so let's pause and see if any questions came up during my section. Back to you, Taylor.
So it looks like we've got one. Have you ever found the wrapping on fiberglass pipe insulation to be hot? If pre-1981 TSI must be presumed to be hot, can you not presume post-1981 is not?
Okay, so two-part question. Have we ever found the wrapping? Yes, particularly a cloth type wrapping. It's not common, but yes, we certainly have found the wrapping over fiberglass to contain asbestos. Other things to be alert for with fiberglass is many times there will be hangers that have a block of solid insulation between the hanger and the pipe, so kind of the underside of the pipe. Because the fiberglass, if you put the hanger there, is going to compress the fiberglass. So many times this hard block of insulation will be concealed under the fiberglass, and that can have asbestos. Also, you can get buttered on material at the ends of the pipe insulation where the sort of raw fiberglass fibers would be sticking out, and a sort of a thin coating gets put on with a putty knife there, and that material can have asbestos also. And of course, the more common, mudded elbows at the fittings and elbows where you have fiberglass on the straight section. The other question, okay, so relates to that OSHA language that I referred to before. So OSHA says that you have to presume that pre-1981 fiberglass, or I'm sorry, pipe insulation contains asbestos. Does that mean that we're okay with presuming that post-1981 does not have it? And the answer to that would be no. And EPA, of course, doesn't have anything to say about 1981 as a cutoff. So from that aspect alone, you wouldn't be able to. Even though, you know, EPA banned pipe insulation back in the 70s, at least the friable type, we can't rely on that. Some of the points I've mentioned earlier, materials sneak in, there's the less than 1% issue, and there's the issue of just regulatory compliance, flat out regulatory compliance. Basically what we're after with asbestos surveying is not so much finding the asbestos, we're trying to prove that there's no asbestos there. Because if we do, then we're going to work on that material with no controls at all, or at least not asbestos controls. So we want to be very sure about that. So that's what we're after. We're doing a robust sampling strategy to try to prove that. And that's what's necessary, yeah, even in that pipe insulation scenario.
Okay, and it looks like we've got a few more here. One being, can you talk a little about NOA in construction?
Right, so NOA is naturally occurring asbestos. This would be asbestos that's occurring in the ground and would come up with regard to excavation, for example, in certain parts of the country, or particularly in California, where we have serpentine as our state rock, and especially in Northern California, it's fairly common in certain areas to encounter. So clearly, with regard to cutoff year, Mother Nature doesn't abide by that. So yeah, you can find it anywhere where there are, you know, the conditions were conducive to form the material in the earth. Those tend to be found along certain geologic areas, and so the starting point is really a geology starting point, looking for the type of formations in the ground that could result in finding asbestos there, naturally occurring asbestos. California at least has written up a whole separate regulation for naturally occurring asbestos, and it lays out how to check for it, what type of analytical method to use, and also then what type of control methods to bring to bear.
Great, and then last question it looks like we have here is there a recommended protocol for sampling during abrasive blasting? Which method for analysis provides best data for contractors?
Okay, so that's going to toss it back to Michelle. I'm going to give up the microphone to her.
And can you repeat the question, Taylor, please?
Yeah, so is there a recommended protocol for sampling during abrasive blasting? And which method for analysis provides best data for contractors?
Okay, so for the first question, you would do the same style of sampling. However, abrasive blasting does generate a lot of airborne dust at the same time, so you need to make sure that you're doing smaller sample durations, but a long enough time in order to get the desired detection limit. So although anybody can collect a sample, that's why sometimes it's necessary, especially for a little bit more complex projects or scenarios like this, where you'd want to use a hygienist to come in there and develop a plan in order to not overload the sample, but also to know when to change it out in order to get a no overloading, but the correct sample duration. But any one of those methods would be sufficient. And in terms of which is the best method, they're both pretty good. There's some people have preferences. I've typically used 7500, now 7500 majority of the time, but recently went to 7603 because the lab is approved to do the work, and that's the method they use. And I've found great results with that as well. So there hasn't been any issues. I guess it's contacting your laboratory that you work with and seeing which method they use and feeling comfortable with the style of work that they do and the reports that they provide you. But both are approved by OSHA for the actual silica standard.
Great, and it looks like that's all the questions that we have currently. And here's Michelle and Steve's contact information as well, everyone. We'll also be sending this out over email later today in case you guys have any follow-up questions that come up. But here it is if you prefer to copy it down now. And again, we'll be sending this out later today. But that concludes our webinar. Thank you all for joining us today. Again, we'll be sending their contact info out later today, and we've also recorded this webinar. So if you would like to receive a copy, feel free to reach out to Steve or Michelle and let them know. And thanks again for joining us, and have a great rest of your afternoon.